My name is Gordon Alderson, citizen of Geelong. My question perhaps is to Professor Stephan firstly. My understanding of the science is that we need to be very careful to differentiate between correlation and causation when it comes to carbon dioxide. Because, as I understand it, as the oceans heat up, they give off carbon dioxide. And so my summation of that is that it's the heating that causes the carbon dioxide, not the carbon dioxide that causes the heating. And further to that, just looking at the numbers, I understand that if in about 86,000 molecules of air, about 32 of those are carbon dioxide molecules, and just one of those, 32, has been caused by human activity. So my question is, with one molecule in 86,000 molecules of air, how can that one molecule, A, be identified as one that's coming from human sources, and secondly, how can it be blamed for heating when it's the other way around?
Okay. No, look, the interaction between ocean temperature and CO2 is what we call a feedback. It's part of a system process. As oceans warm, they give out more CO2, but as there's more CO2 in the atmosphere, it warms the Earth's surface and the ocean zone warm more, and so on. This is the major feedback loop, one of the two major feedback loops that drives the Earth from an ice age to a warm period. So it isn't either or, it's a feedback loop. We know the physical properties of CO2 very well. They do warm the planet. We know the solubility of CO2 in ocean water. It's more soluble in cold water. So you're partly right. But the other part of the equation is CO2 does warm the surface of the planet. Second thing, the amount of CO2 in the atmosphere, first of all, just a slight correction there. The pre-industrial concentration was 280 parts per million. Now it's approaching 390, so it's far more than what you say. But nevertheless, compared to all the other gases, it's very small. So let me address that second part of the question. The important analogies here are, depending on the nature of a substance, very small quantities have a very big impact. Look at the nuclei, a radioactive nuclear material being emitted by the Japanese reactors. That's much, much lower in concentration than CO2, and yet,
if you could just
and yet it has a very large effect. So what I'm saying is that don't compare a percentage of CO2 compared to nitrogen gas, which is inert. The point is, how many billions of tons of CO2 are in the atmosphere? What are the properties of that CO2? How much radiation does it absorb? And how much radiation does it re-emit? Those are all quantitative numbers that we know very well. It's all basic physics. And we know that the amount of CO2, the additional CO2 that we've put in, should raise the Earth's temperature by about 1.2 or 1.3 degrees at equilibrium, and it's exactly where we're tracking. So all the physics adds up. And it doesn't matter what sort of percentages or molecule per molecule you say. We know how many billions of tons are there, we know its properties, we know what it does, and that's exactly what we're observing.